No, not that vector. We are talking about calculus vectors. So, let's actually talk about it. Oops. Vectors. Bro, I really need to get a pencil, bro. What is a vector? So, one of the hardest things to learn about vectors is actually what are they, right? What are they? They aren't. Keep in mind, that's a common misconception. Vectors are not line segments. Rather, vectors are, I guess you can represent them as arrows. They are represented as arrows oftentimes in graphs. So, what are vectors specifically? They are a set of instructions of where you're going. That's a very simple way of explaining. But remember, back then in your first grade, second grade, third grade class, I don't care, whenever you did your graphing classes, you did something like 2 steps, move 2 steps to the right, and 3 steps up. That is sort of what a vector actually is. And you can actually show this using the less than symbol, or like sharp brackets or parentheses, wherever you like to call them, represented as this: 2 steps to the right and 3 steps up. So if it was 3 steps down, it would be -3. This would be -3. Or if it was 2 steps to the left, this would be -2. But what a vector is just, it's a set of directions. So maybe you've searched it up on Google, but vectors have a magnitude. Oops. Magnitude and direction. Or maybe you heard it from the groove vector. But what this means is the magnitude is the length of the vector. So this part of it, let's circle it. This, how long this thing is. So, and also the direction is just which way is it pointing. And you can figure it out using angles, or you can figure it out using instructions like the magnitude's going to the northwest or northeast, or like 35 degrees to the left of north, or 35 degrees west of north, right? There's just instructions that you will be able to see that will show you the direction typically, or you can find the direction using the side lengths, using some trigonometry or some pre-calculus. So I'm going to show you how to calculate magnitude. So what a vector basically is you can actually just represent this as a triangle. So let's actually show you this. This right here, dot, 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 is a triangle. It's a right triangle. So what can you use on the right triangle? You can use the Pythagorean theorem. I don't know how to spell it. I'm not going to spell it. So let's write down, well, the brackets before. So we said that this was, let's say, 2 steps to the right, and 2 steps to the right, and 3 steps up. You know what? Let's make this look better. 3 steps up to, no, 3 steps to the right and 4 steps up. Okay? So the side length of this right here is 3, and the side length of this height right here is 4, or length, whatever you like to call it. So does this look familiar? You can use the Pythagorean theorem here. So let's use the Pythagorean theorem. Let's do square root of 3 squared plus the square root of 4 squared. Well, not plus the square root. I square root all of it at the end. What is this equal to? It's equal to actually 5. It's one of the Pythagorean identities, 3, 4, 5. That's one of them. So the magnitude of this vector would be 5. And sometimes practice problems or instructions of whatever your professor is giving you will tell you the magnitude, but oftentimes than not, they're going to have you solve the magnitude at the beginning when you're first learning vectors, and you can solve it using, well, these instructions. Another way to represent these instructions, right, 3 steps to the right, 4 steps up, is by writing down 3 I hat. I hat stands for the x direction in a coordinate system, and j hat stands for the y direction. So vectors like this, they will they can either be represented as with these less than symbols or greater than symbols, or sharp brackets. I'll just call them sharp brackets from now on. Or they can be represented with I hat and j hat. Now, when you see a vector in the brackets, you're going to represent it with commas. But when you see it with I hat, J hat, or even possibly if you're taking Calculus 3 or Introduction to Physics class, you're going to see a K hat, which is the Z direction. So, but I'm going to talk about that later. But for now, you just got to understand that inside the brackets, you use commas with traditional like coordinates. Like let's say you were 3, 4, right? You would use parentheses. But with the vector, you would use the angled brackets. And again, let me clear up a common misconception. So, a vector is a set of directions. Now, these directions don't have to start at the origin point 0, 0. This right here, this point right here, does not have to be 0, 0. This can be anywhere in space. This origin point could quite literally be, I don't know, 100 billion or like 100, 5. And the set of steps that you would have from this origin point is 3 steps to the right, 4 steps up, or 3 units to the right, 4 units up. And as a result, right here, this point would be 103, and this y would be 9. So remember, vectors are a set of directions, not a line segment, and not a specific point inside of a graph. Now, let me clarify this. Magnitude will always be positive. Your direction could be negative. Directions could be negative, but the magnitude will always be positive. The magnitude is just quite literally the length of the vector. And again, you can solve it using Pythagorean theorem, or likely will be given directions. And if this is hard to remember, just know that it literally starts with I and goes on to J and goes on to K, which is in alphabetical order. So if you ever forget about it, I, J, K. Just remember that I is the start. Another thing that is cool about vectors is that you can add them. Well, what do you mean by this? Well, let's actually erase all this. Let's give you a vector, let's say 5, 8. And also another vector, 10, 3. You can actually add these two, and this will equal to 15, 11. And how I got 15 was I added this, the x components of the vector together to get 15. And I also added the y components together to get the 11 here. So adding vectors are super simple. And what does that look like inside of a graph? I'm going to try to sketch a, I guess, rough example of what this looks like. But let's actually do it like this. But let's say this was the first vector. And then let's say this was the second vector that we're adding, 10 and 3. The resulting vector would be 15, 11. Okay? And let's name this vector, let's actually name this for simplicity, u and v. So whenever you are writing the variable down for a vector or setting it equal to anything, it has an arrow above it. So just so you know that it's a vector, not a point or none of that. And sometimes they'll just name it, like some people just name it as u without the arrow. It doesn't really matter. You can tell by the angled brackets or the I hat or J hat or K hat. So when you actually add these two together, these two vectors together, and let's call this u arrow and v arrow, you get one resulting vector, which is 15, 11. Which vector is that? Well, 15, 11 is actually from the start of u to the end of v. And this right here, this resulting vector, I'm going to use the line thing. This resulting vector is, and let's call this, I don't know, W arrow. This resulting vector is W arrow. So when you add them together, the resulting answer of your two combined vectors is just another vector from the start to the end of your long chain of adding them. And when you subtract vectors, I'll show you that real quick. When you subtract vectors, and let's write down the same things. So the previous one was 5, 8, and let's do minus 10, 3 equal to what? Well, same thing. All you do is just subtract the corresponding values. And what I mean by corresponding, I mean subtract the x values and the y values together. So what happens? 5 minus 10 is equal to -5, and 8 minus 3 is equal to 5. So these two subtracted together, you get this. And these two subtracted, you get this, or this. So what's the difference here? Well, when you're subtracting a vector, I guess an easier way to look at it is you literally just turn this into a plus and then add this to negative. Turn both the vectors into negative vectors, or the opposite values, or whatever, right? And the reason why I say this is easier is because, well, adding vectors together is easier. You can just connect them at the tails. So if you see a minus, you can literally just turn them into negative values, and it's the same thing. Let's actually draw this on a graph. This time I'll need like a full graph. And let's just call this for ease of representing u, and let's call this v. Let's call this w. And I'll draw 5, 8 again. 5, 8 is here. That's right. Looks about right. And -10 on the x-axis, maybe about like here. And then -3 down. So like right here. So this is v, and this is u. And the resulting vector is a new vector. The resulting vector of this operation is a new vector, in where you connect the starting point to the end point. And this is equal to w. And that's how vectors look. Doesn't this look like -5? This looks like this right here looks like this would be -5. Oh no. This looks like this would be -5 and 5, doesn't it? I think I did a good job on drawing this graph. Pat on my own back. Okay, another thing you can do is multiply these vectors. So we covered adding. How about multiplying vectors? Well, you'll learn about cross product another time. But multiplying a vector by a scalar is what I'll talk about today. And a scalar, let's write that down. A scalar value is just a number. A number. So it's not a vector, it's just a number, or a real number. Right? Scalar value, real number. And what you can actually do here is, let's bring out the vector 6, 6, 6. Why not? And we multiply it by the scalar, I don't know, 8. What happens here? Well, the resulting vector turns into 8 times 6. 8 times 6. So you just use the distributive property here. Just multiply whatever scalar you have, or whole number, that you're multiplying a vector by, and use this scalar, multiply everything inside of the vector. What do you get? 8 times 6, and then you get 48. And 8 times 6 again, you get 48 again. So multiplying by scalars is pretty easy. You just gotta multiply all the values inside of that one vector. So I'll have you guys try some of these things out yourself. Go ahead and add a vector, let's say 5, 10, with another vector, 18, really big 18, 18 negative 9. Add these two vectors, solve the problem, and come back to me right when you solve it. Write down on like a piece of paper or something like that, or just do in your head, whatever works for you. So when you add these two vectors, all you have to do is add the corresponding parts. So I'm going to add the x values together in each vector. 18 plus 5 is equal to 23. I'm not going to forget the braces. 10 plus negative 9 is 1. So this would be the answer for this. Adding vectors is just quite literally just fucking addition. Okay, it's easy as hell. Now, let's try subtracting a vector. 10 comma 3 minus negative 15 8. Maybe I'll put 8 here. Nah, let's put like some absurd number. It's like 1,052 or something like that. So go ahead and do this. Okay, now that you're done, remember what I said before? You can just turn it to addition. Especially if you have to graph it, 100% turn it to addition and change the numbers into negative. It's so much easier to actually know which vector you're graphing. Switch this to addition and then find the opposite values if you're graphing the vectors. But for now, we're just adding them together or subtracting them. So 10 minus negative 15, 25. And 3 minus negative 1,052, 1,055. So subtracting is easy. Quick one. Let's just do a scalar. Okay. 5 times 92, vector 92 and 54. What does this equal? So I'm going to have to pull up my calc for this because I'm not trying to multiply like absolutely humongous numbers. So 5 times 92 is 460. And then 5 times 54 is, 5 times 54 into my calc, 270. So this is just the resulting vector. Now, don't try to multiply vectors, as what I said before. Do not try to do this. I'm going to draw this fast. Don't try to multiply them, you know. Like I'd say you have like 80, 50, I don't know. Do not try to multiply them using distributive property. This cross means something completely different, so don't do that. Only multiply vectors by whole numbers or numbers. And just a quick thing, remember these guys? Let's do math of them as well. 9i, 8j hat minus, and let's introduce just a quick third dimension. Don't worry about what this means. It literally just means the same thing. All the rules still apply. You still add everything. Minus, I don't know, 5k plus negative 3i hat plus 2j hat. And let me give you a quick hint here. If you don't have one of the values and the other vector that you have to add doesn't have a k value, it just automatically set to 0k. So that's a quick hint on how to solve this. Go ahead and solve this. So again, I'm just going to add the corresponding values. So what are the I hat values? I hat value of 9 and I hat value of negative 3. Let's add those two together. What do we get? 6 I hat. Okay, now let's add the j values. J, 8 and 2. 8 plus 2 is equal to 10. And then let's add the k-hat values. K-hat, nothing here. Means 0. So we just leave the k-hat alone. 5 k-hat. So this is just another way to represent vectors. You don't have to always see them inside these angled brackets. But you can see them in the I, J, K form, and the math all still applies. And if you're really, really confused, bro, you can literally just turn this into 6. If this looks better to you, go ahead and do that. It's the same thing. Oh, not 6. Oops. 9. You know, if this looks better to you, go ahead and do that. Everyone does math their own ways, you know? So that's all for vectors. This was just an introduction video to help you understand what they actually are and some simple operations that you can do with them. If you have any questions, put it down in the comment section.